A ship at sea faces many challenges. Even in times of peace, we're kept on our guard by the forces of nature. But in times of war, we also have to contend with the weapons of the enemy. In recent years, we've seen the emergence of the anti-ship missile as one of the most fearsome threats in naval history, and we've been developing many different ways to counter it. One way to counter a missile with radar guidance is to confuse its homing system with a decoy. This is Super RBOC, which is a short way of saying Super Rapid Bloom Offboard Chaff. It's a radar decoy system developed by the Naval Research Laboratory and the Naval Surface Weapons Center under the sponsorship of the Naval Electronics Systems Command. The rounds this man is loading contain radar reflective chaff. When an incoming missile is detected, one or more rounds can be launched to quickly form a large chaff cloud overhead. To an incoming missile, it looks like this. A ship presents a certain radar cross-section to the missile's homing device. The missile locks on to this radar reflection as it homes on the target. When the ship fires Super RBOC, the chaff cloud presents a more attractive radar cross-section. The missile, seeing that it has a better target, will home on the chaff cloud and miss the ship. A Super RBOC installation is tailored to each ship. This is a Mod 2 system with 2 launchers on each side of the ship. Ships less than 450 feet long get the Mod 1 system with 1 launcher on each side. And there is a smaller RBOC system for hydrofoils and patrol boats. A power supply for each launcher is installed below decks. There's a control panel on each side of the bridge and a master control in CIC. For ships with no magazine space near the launchers, ready service lockers are installed on deck. Each locker holds 20 chaff rounds, ready to load and fire. Now, let's take a closer look at the system so you can better understand how it does its job. The launcher has 6 barrels set at fixed angles. Each barrel can be fired individually. At the base of the launcher is a safing switch. This ensures that the launcher cannot be fired while it's being loaded. The launcher is loaded by hand, 1 barrel at a time. Each round is fitted with an expendable barrel extension, which is clamped in place as the round is loaded. In the bottom of each barrel is an induction firing device. We'll use this cutaway to show how it works. The firing device contains an excitation coil and a spring-mounted magnet. When a round is loaded, it forces the magnet down. This closes a reed switch in the base of the firing device. The control panel now indicates that this barrel is loaded. When the firing switch is pressed, the coil is energized. This creates a magnetic field, which generates a current in a similar coil in the base of the round. The current fires an electric squib, which sets off the propellant charge. When the round is fired, it starts a chain of events which ends up with a cloud of chaff above the ship. We'll go through these events one by one. As the round leaves the barrel, the propelling gases force these fins open to stabilize the round in flight. This slow-motion view shows how it works. You can see the fins open just as the round leaves the barrel. The propelling gases also operate the safing and arming device. A bore rider locks the mechanism until it leaves the launcher barrel. Then the safing and arming device aligns the explosive train. 3.5 seconds later, when the round is some 600 feet in the air, a detonator fires. This sets off the burster charge, which runs the length of the round. The burster charge shatters the case and throws out 18 macro cassettes full of chaff. Each macro cassette has its own burster charge and delay detonator. When the detonator fires, it splits the macro cassette and throws out small packages of chaff called muffins. Each muffin is wrapped in mylar. A small lead weight packed with the chaff helps the mylar unroll, spreading the chaff over a large area. There's not much chaff in each muffin, but one round contains over 2,600 muffins. The result is that in less than 10 seconds after firing, we've established a large cloud of chaff. That cloud will remain effective for several minutes, even in the rain. In addition to the chaff round we've just described, the system is supplied with a practice round which contains a dummy load and a test cartridge. The test cartridge is used to check out the firing system in each barrel. When the firing button is pressed, the meter indicates a proper fire signal. The system is controlled from either CIC or the bridge. The CIC control indicates the status of the system and the status of each launcher. Firing a round is a two-step process. The operator must depress and hold the arm switch while he fires each barrel. The system can also be controlled from the bridge. The control panels are mounted on either side of the bridge and control only the launchers on that side. Each launcher has its own power supply that converts 440-volt ship's power to 28 volts DC and distributes it through relays. If ship's power is lost, the system can run on batteries for 8 hours. Detailed instructions for operating and maintaining all parts of the system are contained in OP 4485. It provides step-by-step instructions for all operations, from loading to troubleshooting. With Super RBOC properly checked out and loaded, it's ready at a moment's notice to protect the ship against cruise missile attack. As modern systems go, Super RBOC is simple and straightforward. It's designed to be reliable. It must be reliable. For one day, Super RBOC might make the difference between a ship's living to fight another day or never coming back.